Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Thanks again to our Patreon subscribers. We really appreciate your support.
For less than the cost of pretty much everything, because inflation sucks, you can hear us talk about more interesting engineering failures.
Yes, $5 Canadian per month to get more interesting engineering failure episodes. So all of those failures that are fairly simple or straightforward, but are still super interesting, we're covering on our Patreon page with these mini failure episodes. And those come out on the opposite weeks from our regular episodes. So if you want to get an episode from us every week, please subscribe and support our show. Putting podcasts together is a lot of work. It takes a lot of time, and it would just be nice to cover some of the expenses that come along with that. So we really appreciate your support putting this show together.
In our last episode, we covered the first part in our Wind Turbine Failure series. We talked about the most common causes of wind turbine failures, which is blade failure. We also talked about optimizing wind farms and how wind energy has impacted Alberta and Germany.
Yes, we have. And we're back for more wind turbine failure discussion with Leanne. She's a mechanical engineer working in the waste to energy side of the renewables industry, and she came all the way to us from Germany, which was a super cool experience.
She didn't actually travel all the way from Germany to hang out with us, but virtually she joined us from Germany.
She joined us virtually, but it's still really cool. And having worked on wind turbines at the beginning of her career, Leanne's teaching us a thing or two about how wind turbines work and how they fail.
To recap, before we dive in, the wind turbine includes a foundation, tower, 3 blades, and a cell which houses all of the mechanical components, a gearbox, and a generator. So as the blades spin from the wind, they turn gears in the gearbox, which are connected to the generator to turn the mechanical energy into electricity. We've already talked about blade failures. Next up, we have generator failures.
This week's episode of Failurology is brought to you by Long's Long Pants.
They're long pants made by Longs.
Not to be confused with shorts. These are different.
This seems pretty self-explanatory from the name.
But yet, here we are, explaining long pants.
Long's Long Pants.
Okay, the next failure that we're going to talk about is generator failure, and this is the second most common type of wind turbine failure. So the generator is the piece that creates electricity. It converts that mechanical energy, which is the turbine spinning around in a circle. It converts that into electrical energy. And so when the generator fails, you don't get any power. And again, that's pretty straightforward, but I do think that from researching this, it seems like if any part of the wind turbine fails, it doesn't produce power. They all seem to be pretty integral components. The designs of wind turbines do seem to be pretty, I'll call them lean, in that every component is important and every component contributes. And there isn't really anything that's sacrificial from what I can tell. Everything matters and everything needs to stay functional. There's a lot of common reasons that the generators can fail. And so I'm just going to run through those. One of the most common is probably wind loading or weather extremes, just putting extra stress on the generator. Thermal cycling, which is probably a bigger factor in areas like Canada, where we see such extreme summer and winter temperatures. And, even that freeze thaw has a pretty big impact on other parts of Alberta. Like, it's pretty challenging on roads and buildings and other infrastructure. So I can only imagine the impact it has on wind turbines.
Yeah, just want to say too, for offshore wind turbines, thermal cycling is pretty big also, because it's the air is so humid, and in the day, if you have all this humid hot air inside of the nacelle or the cabin at the top where the generator is, and then at nighttime it cools down, and then you're getting condensation inside where all the electrical components are, and it's definitely one of the causes of failure, and it's of concern for some of the designs of the offshore turbines.
Great point. I've been living in the desert too long. I think I forgot about how humidity plays into that. Yeah, that's a great point. You see that impact so much greater in the air temperature because it's holding on to all of that water vapor. The bearings, mechanical or electrical failure can happen to the bearings. Excessive vibration, voltage irregularities, cooling system failures are another big one. I'm biased working in HVAC. Generators only like to run up to 40, maybe 50 degrees Celsius. Anything more than that becomes too hot for the generator, and different components start to fail, or it doesn't run as efficiently. But when it's 30 degrees outside or warmer, 40 degrees like we saw in some parts of Europe this past summer, it's really hard to keep places cool when the ambient air you're using to cool them is only a couple degrees colder than the maximum temperature that equipment wants to run at. And so that's definitely something that has to be factored in when you're sizing those cooling systems, which are usually, I would think, ambient air. There could be manufacturing or design faults, which we saw with the blade failures that we just talked about. Stuff happens, humans make mistakes, things happen. You've got to have processes in place to prevent those tiny design mistakes from making it all the way through manufacturing, but they don't always get caught. And so stuff does happen. Improper installation can also be another factor. Lubricant contamination, if it's not the right lubricant or it's got some other sediment or grit in it, either from the air or from the engine itself, those can also lead to other issues. It's just like the oil in your car. If you don't change the oil and put clean oil in, and that oil is dirty and has a bunch of sediment in it or different metal shavings in it, it's just going to create more damage within the engine. And then lastly, inadequate electrical insulation. So all of the electrical components typically need to be insulated. Specifically, I'm talking about wires, but I'm sure there's others that I'm not thinking about right now. And if those aren't insulated, then the coatings on those wires can melt and short or be damaged in some other way. And so that's also an important piece. Like all good engineering design, a comprehensive maintenance and repair program is important. And in the case of these wind turbines, it'll help improve reliability and longevity of the turbines.
Yeah, so let's talk about a couple of different generator failures. First, we'll talk about a fire failure that happened at Juniper Canyon Wind Farm in Klickitat County. This is south of Bickleton, Washington. Incidentally, home of the Bickleton Carousel Museum, if you're ever in the area. At around 2 p.m. on July 20th, 2019, there was something in the nacelle. So again, this is the cabin at the top of the tower. Something in the nacelle caught fire and spread to the blade. And the blade fell to the ground and caught the grass on fire. And that fire burned up about 300 acres. There was no reported injuries or structural damages from the grass fire. The Juniper Canyon 250 megawatt wind farm is consisting of 63 2.4 megawatt turbines, and these have a 100-meter diameter rotor, and 65 1.5 megawatt turbines, and those are probably on the order of 70 millimeter diameters. We didn't find a report on the fire incident, but very likely a fire in the nacelle would have been started either at the mechanical brake of the generator or in the converter capacitor cabinet. So it's either an electrical fire or maybe something's overheating in the brake.
One thing to add to this too, Washington State, if you're going north to south, Washington State, then Oregon, and then California, and those areas are super prone to wildfires and some pretty catastrophic ones at that. It's pretty dry there, lots of desert, also lots of vegetation, trees, bushes, etc. And so this fire had the potential to be really, really devastating had it gotten out of control. 300 acres is still a lot, but that's almost lucky that it didn't go worse. There was a couple years ago, a family was doing gender reveal party. They set off some fireworks, which they should not have done. And they started one of the worst wildfires that California has seen in years. And it's just really, really dangerous. Just something to consider, an offshoot from these turbines is if they're in really dry areas, those fires can be so much more catastrophic than just taking out the wind farm, which in itself is already really bad, but they can be so much worse.
Yeah, it makes you wonder too. So a wind farm like that, it's pretty big. There was 63 plus 65 wind turbines, so over 120 wind turbines, and you got to wonder what their emergency response plan is like. Bickleton, Washington, I forget what the population was, but it's like a couple of hundred people. So I don't know, probably they have a volunteer fire department, and, are they well equipped to manage a fire like that? If it had been bigger than, obviously it only burned up 300 acres, but yeah, makes you wonder how much forethought they had when they were building this.
Speaking of generator failures, one of the ones I'm going to talk about now is the original Peta-Witt wind farm. And this was a wind farm that was composed of 12 1.75 megawatt turbines with a total farm capacity of 21 megawatts. And this was located in Uitgensplaat, Netherlands. I think I'm pronouncing that right. So this turbine, it was commissioned in 2003. And on the afternoon of October 29th of 2013, so about 10 years after this was commissioned, one of the turbines caught fire in the nacelle while 4 mechanics were doing routine maintenance. 2 of the mechanics were able to use their constant rate descenders and essentially safely belay themselves or descend to the ground level. Unfortunately, 2 of the mechanics, they weren't able to deploy their constant rate descenders, and unfortunately they did perish in this incident. So the constant rate descender, if you're not familiar with it, I assume this is similar to kind of the self-belay systems that are used in various indoor climbing gyms. So the constant rate descender, it just allows descent from various structures or ledges or places above the ground at about 2 meters per second, which is quite a bit slower than you would land after just hopping on 1 foot. So it allows a nice, slow, constant rate of descent down to the ground. So the fire atop the 76-meter tower, it was too high, unfortunately, for the first responding firefighters to reach. Leanne did briefly mention in one of the previous examples just about possibly being a volunteer fire department. For these wind farms, I mean they're massive towers, and to support that sort of firefighting capacity, that's something that a major city would have with an aerial firefighting team. And there's also just a limit to how far up in the air ladders from trucks can go. So unfortunately, in this incident, it was too high up for the firefighters to respond to, and like I mentioned, the 2 mechanics, they were trapped in this nacelle while it was on fire, and it's speculated that they couldn't reach their safety devices through the flames. So by the time that specialty firefighting equipment arrived for rescue, it was too late for the 2 trapped workers, and both the men died as a result of this incident, and the fire was extinguished later on in the evening. The suspected cause of the fire, it was a short circuit due to a dropped tool. The employees, they de-energized a ton of the voltage. Most of the voltage systems, the majority of the components were de-energized prior to commencing work. So it sounds like they did everything that they should have been doing. It just, they dropped the tool and it short circuited, a component there that led to the fire. I know typically for working at heights, I've done some projects where they've been, fairly high up, or, even just, maintenance activities around the airplane hangar. I've typically tied off all of my tools just to prevent them from dropping onto people or other things that are below. And a lot of the sites that I've been to, it's been a requirement that tools are tethered either to the man lift or to people that are operating those tools, especially if they're hand tools or they can be dropped.
Yeah, I've seen it also where they ask you to lay like a fire blanket down so that if your tool does drop, it falls into a fire blanket.
Yeah. And again, unfortunately, a lot of these, rules that are on sites, things like fire blankets, those largely come as a result of somebody, being seriously injured or, passing away in an incident like this. So we couldn't find anything whether a fire blanket was required for the site or whether there was, the need, tie off tools or have the tool secured. Yeah. And unfortunately, a tool dropped and it just dropped in the wrong spot and short circuited, a component that led to this fire, where two people wound up passing away. So remaining 11 turbines in this farm, they were decommissioned in 2021, and they were replaced by 7 new 4.8 megawatt Nordex N133 turbines for a total new capacity of 33.6 megawatts. So they did increase the capacity of the wind farm. There's less turbines there right now, but overall, they did increase the generating power of this wind farm.
I just want to piggyback off the dropped tool comment and tying off or tethering those tools. That's just super important. I think another factor, it's not just dropping the tool necessarily or having it slip out of your hands, but also wind can be a big factor. And these people are working on turbines way up in the air. The wind turbine itself is probably in an area that's not around, the general public isn't standing underneath and at risk of being hit by something that's falling out of the turbine. But in construction, that is certainly an issue. And I've definitely heard stories or seen the results of what can happen when the wind picks up and blows something off a building, to have it land on the street 10, 12, 20 floors below and seriously injure or kill passersby on the street that thought that, they were just walking around the city taking in the sights, and unfortunately their lives were changed by something that fell off of the building due to wind. So tying down and securing tools is really, really important for all types of projects, not just for wind turbines or construction specifically.
Yeah, that's interesting. You talk about the wind picking up, and it's a great point because when you're up in the air like that, you're not just standing still. So if there is wind, the rotor is not turning while they're doing maintenance up there, but there's a very good chance that the tower is moving back and forth a little bit with the wind. When I got to do my summer student exchange when I was in my undergrad, we got to do a tour of a wind turbine. So we climbed up to the top of the tower and we got to look at the generator and everything on the inside in the nacelle, and you can feel the wind blowing up there. It's a bit crazy, and we got to poke our head out of the trap door at the top and have a look outside. But yeah, you can definitely feel the wind blowing back and forth when you're up at the top of the tower there. So it could have been I don't know if it was very windy that day, and maybe they were just being jostled around at the top of the tower.
Yeah, that's a great point. Also, I have a bit of a fear of heights, so my hands are sweaty just listening to that story.
Yeah.
I love heights. I would love to go on a tour of a wind turbine.
It was crazy. I've never held on to a ladder so tight. I mean, we had harnesses on and you're hooked up to the ladder the whole time you're there, but it's a long ways up and yeah, it was freaky but so fascinating. That was awesome.
Do you climb up inside or outside?
It's on the inside.
And is it like stairs?
The one that we were in was just a full ladder all the way up. And I don't remember, there probably were rest stops partway up, but it was a very long ladder climb.
Yeah, that's not for me. I don't think that's for me at all. It's cool though, but not for me. Okay, so moving along to the third type of failure that we're going to talk about today, which is gearbox failure. And we're kind of going from the most common to the least common, but these do still happen. Most gearboxes in wind turbines don't last more than 10 years. They're supposed to last 20 years. That's their design lifespan, but most of them fail well before that point. And we found a 2020 article that told us that gearboxes fail, about 1,200 of them fail annually, which is quite a lot as a standalone number. But I think when you look at the number of wind turbines in operation, that's not a crazy number. It does seem like a reasonable number. I mean, failure and maintenance items are definitely par for the course when you're dealing with this type of equipment. Bearings and gears make up about 96% of the failing components within the gearbox, which is not surprising. Those probably also make up almost 96% of the gearbox itself, and those are the moving parts. So it's no surprise that those are the pieces that are failing. The gearbox itself represents about 13% of the cost of the turbine, which also seems pretty reasonable. I would assume that the blades and the foundation are the most expensive components just because they're the largest and the most technical pieces to design. Whereas gearboxes, while there are advancements that do happen, I like to think of them as somewhat bulletproof. I mean, they're gears that are spinning and working together, but their design has been pretty constant. There's maybe changes to the different materials that the gears are made of, or maybe the depth and spacing of the gear teeth may change over time, but in theory, gears are really old technology. They've been around for hundreds of years, and so I feel like we've kind of got that dialed in. So I'm not surprised that they're only making up 13% of the cost of the turbine. Some contributing factors that go along with gearbox failure, and these are also very similar to the contributing factors that lead to generator failure, which again is not surprising. Those two components do work very tightly together. It's just like in your car, the generator is the engine and the gearbox is the transmission. Those two components are working in tandem. And so the contributing factors for the gearbox are dirty or water contaminated lubrication. Dirty could come from improper lubricating material or substance, but it could also come from, if the gears are starting to wear, the metal shavings will slip into that lubrication and then kind of sends them throughout the gearbox, and then they're starting to impact other components. Improper bearing settings. So like we saw with the generator, significant temperature fluctuations can also impact the gearbox. Improper or infrequent maintenance and servicing. These are kind of challenging to get to, and there are a lot of them, so that's not overly surprising. And then transient loads leading to sudden accelerations or load zone reversals, which I think the weather is probably playing a big impact on those when the wind picks up or slows down really suddenly.
Yeah, so one of the examples we'll talk about first is that in the town of Hornslet, located on Denmark's eastern side, and they commissioned a wind park that has 5 600 kilowatt turbines, and that was in December 1996. On the morning of February 22nd, 2008, a repair team arrived at site to service the brakes after it was making some strange noises. Previously to this inspection, there was a routine inspection beforehand that had also noted that the gearbox was making abnormal noises. They had planned for specialists to perform an inspection at a later date. On the morning of February 22nd, the brakes were repaired and tested, and by the time the technicians were ready to bring the turbine back online, the wind had picked up considerably to 25 kilometers per hour and gusting up to 50 kilometers per hour. As the turbine was restarted, the technicians heard a noise coming from the nacelle, and the technicians immediately initiated the shutdown sequence. Just as they were shutting it down, they heard a large crash and the tower began to shake violently. And there were cables falling down from inside of the tower, so they were not sure exactly what those cables were. Either they were power cables or control cables. And the rotor had stopped turning abruptly, and then it started to turn again very slowly. The technicians at the base of the tower, at this point, they've noted that they have lost all control of the turbine. They aren't able to apply the brakes and slow it down. They aren't able to make any adjustments. And from the outside, they can see that the air brakes at the tips of the blades have broken off. And so then they evacuate the area, realizing that there's a catastrophic failure. So the technicians notified the police and they contacted the nearby neighbors and evacuated everyone within a 400-meter radius of the out-of-control turbine. The rotor at this point is continuing to pick up speed, and by now it's far exceeding its design limit. So like I said before, the design limit is 25 meter per second wind speed and 90 kilometers. But without any controls, they're not able to change the pitch of the blades to allow it to slow down. So the rotor continues to pick up speed, and after 2.5 hours, blades just collapsed. They contacted the tower and shattered, with pieces flying as far as 500 meters away. And the tower also buckled at the point of contact. The top half of the tower broke off and fell to the ground, but fortunately, nobody was hurt in the incident. The investigation following the incident confirmed extensive gearbox damage. The high-speed gear teeth were totally ground down. It's suspected that the loud noise heard during the shutdown sequence was the gearbox failing. It's also suspected that the abrupt stop of the motor caused the air brakes at the tip of the blade to break off. So if we just have a look at what's happening inside of the nacelle, so the mechanical brake it's on the high-speed shaft in between the gearbox and the generator. So when the gearbox failed, now the mechanical brake is no longer connected to the low-speed rotor, which is still spinning. After the investigation, the event was deemed to be a series of unfortunate events, and there were no official corrective actions were assigned, except to stress the importance of timely maintenance performed by qualified personnel. So this is referring to the gearbox inspection that they had planned and had not done yet.
It's a pretty extensive failure, and I think, it started with the gearbox, but it does cover kind of a larger range of failure, with blades being destroyed and the foundation also being destroyed and the tower kind of collapsing on itself. It's pretty catastrophic.
So we did find an example of another gearbox failure, and this is in a wind farm in Northern Ireland in Skega. I believe that's how you say it. It's probably not how you say it, but I'm going to go with that. And this is located on the Murley Mountain in County Tyrone, and there were 8 2.5 megawatt turbines on site that were commissioned in 2011. So around 9 p.m. on January 2nd, 2015, a turbine had collapsed at the Skega wind farm. Nobody was hurt in this incident, which is good, and the debris, they were confined to the wind farm site. So again, ideal, debris not flying everywhere. The area was secured and the other 7 turbines were shut down as a precaution. So the wind speed at the time of the incident, it was around 35 kilometers per hour, which is well within the design of the turbines. Yet some people reported that they saw the blades spinning out of control. So to me, like 35 kilometer an hour wind, every wind turbine should be able to handle that. I think you'd want wind speeds kind of around like the 30 plus kilometer range. So yeah, certainly well within the design speeds. We weren't able to find too many details about the investigation, but it was reported that the investigators found a glitch in the blade pitch control system, which allowed the rotor to go into an overspeed condition. So the operators here on site, they did make several attempts to recover, but they were ultimately unable to bring the turbine back under control. So the operators, they don't travel to site, and they did contact the landowners in the area just to warn them about the situation. Again, like we saw previously, out of control turbines, not a great situation for the wind turbine or for the people that are involved. Eventually, one of the blades fractured and the entire tower collapsed under the momentum of a massively imbalanced rotor. Once you lose one of the blades, I think you've pretty much lost the rest of the turbine. Like, it's just going to destruct in some manner. So once a glitch was identified, though, an additional protective measure was implemented on the remaining 7 turbines at the Skega wind farm. Several rigorous safety tests were performed on the other 7 turbines before they were brought back online. So again, this sounds like they've taken the correct approach on this. They've shut things down early on. There's been an abundance of caution. They've investigated the cause of the failure. They've come up with a reasonable solution. And, further investigation, they did identify that the glitch was only applicable to turbines of the same generation from that turbine manufacturer. And we presume that the others, approximately 1,600 turbines that were in service, also received this protective measure. So this was the first fault for this make and model of turbine. The local health and safety executive also requested that the wind farm operator update their site emergency procedures, especially in procedures for notifying the public of imminent safety concerns.
All right, and we have one other gearbox failure that we want to tell you about today, and this one happened on May 2nd, 2009. One of the turbines at the Tehachapi Pass wind farm spun out of control. This wind farm is located north of LA off of Highway 58 and Sand Canyon Field intersection.
I've actually hiked through this wind turbine farm. It's fairly close to the Pacific Crest Trail. Actually, I believe the Pacific Crest Trail goes through this wind turbine farm. It's really cool, at least for me to see up person and close. I did hike through this. I believe it was right at the evening as the sun was setting. So I have some great pictures from this wind turbine farm.
I didn't know that. That would be really cool.
I'll send you some to add to this episode page.
This wind farm is home to about 3,400 turbines producing over 700 megawatts of power. So I don't think this is necessarily the largest wind farm, but this is definitely up there with all the other big wind farms. And the turbine that spun out of control was located about 1,400 feet from the highway, and as a result, the highway was closed. Which was a great idea because the turbine ended up disintegrating a couple days later, leaving a turbine-less twister tower in its place. The cause of this failure was unknown, but runaway turbines are typically caused by bad brakes or gearbox failure. And the only way to stop a runaway turbine is to wait for the wind to die down, which is very unfortunate because you want to do something about it, but you kind of just have to sit there and let it tear itself apart and make sure everyone around it is safe. Then once the winds died down, you can go and investigate further.
On to the fourth major cause of failure in wind turbines. This is the least common type of failure. It's a tower foundation failure. These are obviously structural failures relating to the tower or the foundation of the wind turbine. Typically when you design a wind turbine, or I assume when you design a wind turbine, you have to take into account the weight of the turbine and all of its components, but also the forces that are exerted onto the base and foundation from the wind on the turbine, the ambient temperatures, precipitation, other forces, other factors, other external factors that are going to impact the foundation of the wind turbine.
Okay, so let's have a look at Chatham, Kent, Ontario. There was a wind farm there. On January 19th, 2018, there was a wind turbine that had collapsed from the center. And the turbine was one of 52 at that facility. They've been running since 2011, so that's about 7 years. The remaining 51 turbines in that wind farm were shut down while the failure was being investigated. The failure of the tower itself is rare, but collapsing from the center is even more rare. Investigators suggested it was a failure of the structure design instigated by extreme load, but they didn't give much more information than that.
So I just want to jump in. Chatham, Kent, Ontario is located not that far from Windsor. It's about halfway between Windsor and London, Ontario, which is south of Toronto, and very close to the area that I grew up in. And I wanted to jump in here because there was no wind turbines there when I was growing up. And then in 2003, there was what we did an episode on it, actually, the Northeast blackout. Due to a software bug, power was knocked out to 8 northeastern U.S. states and the province of Ontario. Now, Quebec was spared from this because Quebec has a lot of other power sources. I think they use a lot of hydro, but they're more independent, whereas Ontario was buying a lot of their power from the US and were then kind of at the mercy of that blackout. And so I saw a lot of big moves that Ontario took to diversify their network, put more safeties into the grid to keep it from being overloaded, especially in the summer, but also to have their energy providers be a little bit more independent and not have to rely on the US for power. And so there's been a huge influx of turbines over the last couple decades, which I don't think everyone that lives there loves. Some people probably don't mind. I think a lot of people hate them. I think they're really cool, but I don't live there. So it is a bit different for me to go back there and see all these turbines that have popped up. But yeah, I just thought that was cool to see this one in this list. I mean, obviously, normal people probably don't get excited about failure the way that I do, but I just thought, oh, I know where that is. So that was pretty cool.
Another example we have is in June 2017, there was a wind turbine at Shannon Wind Farm, which is in northern Texas, and this turbine had collapsed. This was one of 119 turbines on that wind farm. Only the bottom portion of the tower was left after it had failed, and the rest of the top of the tower laid on the ground. The wind farm was shut down for a few days while they investigated the failure, and a new turbine was eventually installed to replace the broken one. A spokesperson said that this is an extremely rare and isolated incident. Here's another example. On December 27th, 2009, one of the 20 wind turbines at Fenner Wind Farm in Madison City, New York, had collapsed. They said it was a 187-ton structure that just fell over into the middle of the field. A formal report was never released. The Forsnick engineers did rule out shoddy construction and deficiencies in the construction materials. The company reinforced the remaining towers with 4 to 6 tons of steel and 10 truckloads of concrete. In May 2009, we also have a 60-meter tall wind turbine in North Palm Springs that crashed to the ground, and witnesses say it was spinning out of control before it crashed, but the official cause was not published. So it seems like we have a lot of failures that if the rotor is going out of control, I think what happens a lot of the time is the blade flexes enough that the blade is contacting the tower, and then it seems to weaken the tower at that point.
This has been a really interesting episode. I said this at the top, but we normally look at one specific failure and talk about why that failure occurred and the different lessons learned and ways to prevent future failures of that nature. This episode was really cool because we looked at all of the different ways that wind turbines do fail. And so I think we got kind of more of a wide-ranging view of all of the different things that could go wrong. I also learned a lot about wind turbines, which is always a fun piece. Thanks for joining us, Leanne, and sharing your expertise on wind turbines and helping us understand and parse together what's going on. Greatly appreciate you joining us for this episode.
Oh, it's my pleasure.
Yeah, thanks so much for joining us from a completely different time zone than what we currently live in.
Yeah.
So there you have it. The most common causes of wind turbine failures. Whether they're spinning out of control, catching fire, or falling over, getting a handle on why and how wind turbines fail and improving their design is a critical step in the diversification of our energy programs. When the wind turbine isn't working for whatever reason, it's not generating any power.
For photos, sources, and an episode summary from this week's episode, head to failureology.ca. And I will say, because we've talked about so many failures, that the source list for this episode is probably the longest we've had so far. There are so many articles and videos linked on this episode's webpage. If you're enjoying what you're hearing, please rate, review, and subscribe to Failureology so more people can find us. If you want to chat with us, our Twitter handle is @Failureology. You can email us at thefailureologypodcast@gmail.com. You can connect with us on LinkedIn, or if you're listening on our Patreon page, you can message us right on there. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode where we'll talk about the Boeing 737 MAX, which is one that's been on our list for a while. I'm really excited to talk about this one. And it's the plane with the, quote, safety system that no one knew about. Bye everyone. Talk soon.